Hello, students. Very recently, I came across this quote by an American mathematician, Mr. Richard Hamming, and I quote him: probability and statistics nowadays have become a necessary tool to understand many diverse things, and one cannot simply choose to ignore them, not even an average student. And that's the reason we are here to understand this subject to its very core. Hello, everyone. My name is Pankaj, your very own maths mentor for Cambridge Mathematics. I welcome you all on your journey to score that perfect A star in your AS and A levels exams. Students, in this session, we're going to start solving a question paper from AS Probability and Statistics 1, October November series from the year 2021, and the question paper code is 51. So without much ado, let's begin. So let me quickly go ahead and share my screen. So you can see that's the probability and statistics 1 question paper from AS. The year is 2021. The series is October, November, and the question paper code is 9709/51. Students, before you begin solving the question paper, it's very important to go through the instructions. So the instructions, the important ones are these ones that you need to take care of. First of all, you must show all necessary working very clearly. No marks will be given for unsupported answers from a calculator. So students, it becomes very much important. It becomes necessary for you to write all the steps in detail wherever it is possible. So show your working, right? So that gives a confidence to the examiner that the student knows the topic very well. So make sure that you write each and every step. The next important instruction that you should take care of is any non-exact numerical answer should be written up to three significant figures, and if it's an angle, then up to one decimal place, unless and until a different level of accuracy is specified in the question. So these are two very important instructions that you should always keep in mind while solving the question paper. Other instructions are all the general instructions. The question paper is for 50 marks, and the time allotted to complete this entire question paper is 1 hour and 15 minutes. So students, I'm going to start solving the very first question. Now, when it comes to start solving questions, it becomes very important for you to understand what topic the question belongs to. Okay, there are a lot many topics that you have learned in this particular subject, so it becomes very important before you start solving the question to identify where this question is from, which topic does it belong to. So you can see the first question. It says two fair coins are thrown at the same time. The random variable x is the number of throws of the two coins required to obtain two tails at the same time. The first sub question says find the probability that two tails are obtained for the first time on the seventh throw. And the second question is find the probability that it takes more than 9 throws to obtain two tails for the first time. Now, before I start solving the question, have you people recognized where this question belongs to? Which topic is it from? So if you have identified, it's very good. And if not, let's try and understand where this question is actually from. So the question says that two fair coins are thrown at the same time. So that's your trial, right? That's your random experiment. You are tossing two coins at the same time. So I can first of all write my trial, right, students? So trial here is two coins are thrown at the same time. Two coins are thrown at the same time. Now, students, if two coins are thrown at the same time, can you write the sample space? Can you identify what the sample space is going to be? How many outcomes are going to be? So if you take one coin and you toss it, you get head or tail, right? The outcomes are head and tail if one coin is tossed. If two coins are tossed, then there are total four outcomes, isn't it? So the formula goes like this: number of outcomes raised to number of objects, right? So we have two outcomes of one object. So if you take one coin, it can have two outcomes. Raised to number of objects, there are two objects, so 2 raised to 2, the answer is 4. That means there are 4 outcomes when 2 coins are tossed. And what could be the outcomes? So both the coins might show heads, right? So that's HH. One of the coin, the first coin might show a head, and the second might show a tail, or it might be the first is showing a tail and the second one is showing a head, and finally both of the coins are showing tails. So n of s, the total number of outcomes is 4 here. Now the question says find the probability for what? So now before you go to the question also says the random variable x. Now you know what a random variable is, right? So x is going to take some values. It can be 0, 1, 2, 3, 4 and so on. It can be a continuous random variable. So here x is a random variable, which is what? Number of throws of the 2 coins. So number of throws. So how many throws are required for the 2 coins? First throw, second throw, third throw, and so on. How many throws are required to obtain 2 tails at the same time? So imagine this action that you are actually performing. Take 2 coins in your hand and you toss them. You toss them, right? So that's the first time you have tossed the 2 coins. And the probability is needed for what? X is a random variable. X is the number of throws required to get 2 tails at the same time. So it might happen that I have tossed 2 coins, and in the very first attempt I got both the tails, right? Both of the coins are showing tails. So I am successful in the very first trial. Or it might happen that both the coins are not showing tail, one of them is showing, or none of them are showing tails. So I have to repeat this experiment for the second time. So again I take the coins, I toss them for the second time. So this time I might get successful. So the first attempt was an unsuccessful attempt. The second attempt is a successful attempt. So this time I've got both the coins showing tails. Or it might happen that even in the second attempt, I am not successful. So I'll have to repeat this procedure for the third time. Even in the third attempt, if I'm not successful, I'll have to repeat it for the fourth time, or the fifth, or the sixth, or the seventh, or the eighth, and so on. I will keep on doing this until I am successful. So x is the random variable, which is nothing but what? It is a number of times you are tossing the coins so that you get the coins showing tails. Both the coins should be showing tails for the first time, right? So you want to find the probability that the 2 tails are obtained for the first time on the 7th throw. It means what? The first throw was unsuccessful. The second, the third, the fourth, the fifth, and the 6th throw. Up to 6 throws, we were unsuccessful. We did not get both the coins showing tails. Right? In the 7th throw, what happened? 7th throw, we were successful. Both the coins are now showing what? Both the coins are showing tails. So this is what I want to find. So this question belongs to which topic, students? Yes, you have rightly guessed it. This question belongs to geometric distribution, right? Isn't it? So we have probability distribution, we have binomial distribution, we have geometric distribution. So this topic is from geometric distribution. And if you recall, the formula for finding the probability for the rth trial to be successful. So probability of x equal to r is given by, so what do you mean by probability of x equal to r? So the rth trial was a successful trial. If the rth trial is the successful trial before the rth trial, which is r minus 1 number of trials, so for this r minus 1 number of trials, we experienced a failure, right? We have experienced a failure. So what's the probability of failure and what's the probability of success? So if I denote small letter p, so that's the probability of success, and the small letter q is the probability of failure, right, students? So for r minus 1, we were not successful, we experienced failure. So the probability of experiencing failure is q, so q raised to r minus 1, right? So for r minus 1 trials, we were a failure, so q raised to r minus 1, and the rth trial was a successful trial, so this is multiplied with p. So that's what the formula is for probability of x equal to r when you have a geometric distribution. So in our case, what is success here? What is success? Getting two tails at the same time is success when two coins are thrown, right? So what's the probability of success? So in our case, P is equal to what? Getting both the tails, both the coins are showing tails. So that's one outcome when you have both the coins showing tail, and the total number of outcomes is 4. So we know that the probability is what? The number of favorable outcomes divided by the total number of outcomes. So probability of success is 1 upon 4. What would be the probability of failure then? It's 1 minus P. So that's 1 minus 1 over 4. That's 3 upon 4. Right? So I have the probabilities of success and failure. I simply take them and put up in my formula. So I have to find probability of X equal to what? Which trial is the successful trial? So we got two tails for the first time in the 7th throw. So X is equal to what? 7. The value of R is 7, right? So I can have the value of Q, which is 3 upon 4 raised to what? R minus 1. So R was 7, 7 minus 1, that's 6, multiplied with P. So P is 1 upon 4. So what do I get now here, students? I'll be getting 3 upon 4 to the power 6. So 3 divided by 4 to the power 6. And this multiplies with 1 upon 4. So I'll be getting here the answer as 729 divided by 1, 6, 3, 8, 4. So if I want the answer in fractions, it is 0.044494 and so on. So I want the answer up to 3 significant figures. Right? You remember the instructions which were given at the very beginning of the question paper. So the answer is 0.04449 can be written as 4, 5. So that's how the first sub question can be solved. So you just needed the probability when R is equal to 7. So that has fetched you 2 marks. Let's go to the second part of the question now. Again, an interesting one. Find the probability that it takes more than 9 throws to obtain 2 tails for the first time. Now try and understand this. This is very important. Find the probability that it takes more than 9 throws. So when I say more than 9 throws, does it mean that you are successful in the 10th throw? Students, you might think that if I need more than 9 throws, that means I might be successful in the 10th throw. But you want to understand, it is not the only possibility. When you say more than 9 throws, it can be the 10th throw, it can be the 11th throw, or the 12th, or the 13th, or the 14th, and so on. It can be anything, right? So it is just more than 9 throws. How many throws is not mentioned over here. So you need to again understand the question very carefully here. You want to find the probability of X greater than what? Greater than R, isn't it? So do you recall that if I say that I am successful after R number of trials, so the R plus 1th trial, or the R plus 2nd trial, or the R plus 3rd trial, or the R plus 4th trial, or the 5th, or the 6th, and so on, might be the successful trial. Getting that? So let's say here, if I want to write like this, so I was unsuccessful for the first R number of trials, right? Greater than R, when I say, it's like after the Rth trial, we were successful. So for the first R trials, I was unsuccessful. So when can I say I am successful? In the R plus 1th trial, right? So for R number of trials, we were unsuccessful. So Q raised to R, and then we got successful. So it's P. Or it might be like I needed R plus 1 number of trials. So I can have Q raised to R plus 1 into P, or Q raised to R plus 2 into P, and so on. The terms will keep on coming like this. Let's take it in a more simpler way. Let's take the example of this question itself. So more than 9 throws, it means what? I might be successful in the 10th throw. So Q raised to 9. So 9 throws were unsuccessful and the 10th throw was successful. Or, so plus, right? We were successful in the 11th throw. So Q raised to 10. So for the first 10 throws, we were unsuccessful. And in the 11th throw, we were successful. Or we were successful for the first 11 throws and we were not successful. We were unsuccessful for the first 11 throws and we were successful in the 12th throw, or we were unsuccessful for the first 12 and successful in the 13th, and so on. It will keep on coming like this up to infinity, right? So from all the terms you can take out p and q raised to 9 common. So q raised to 9 is common, p is common. What is left? So in the first term 1 is left, second term q, third term q square and q cube, and so on will keep on coming. And do you know that q is less than 1 here, right, students? We know that q is less than 1. So this is an infinite series whose sum is expected. So s infinity, if you recall, is given by a upon 1 minus r. A is the first term. In our case, it's 1. 1 minus r is a common ratio. That's q. 1 minus q is p. So it's like 1 upon p. So you got q raised to 9 p into 1 upon p. P and p gets cancelled. You got q raised to 9. So that means probability of x greater than 9 is what is q raised to 9. So you want to remember this formula. Okay, I've given you the explanation. You remember it very properly now. So for probability of x greater than r, the probability is given by simply q raised to r. So in our case, so I'll just erase all these things very quickly so that we can complete our solution. So knowing the formula will definitely help you, right, students? Knowing the formula is definitely going to help you. So I can now write over here q raised to r. So what's the value of q, students? If you recall, the value of q was 3 upon 4. So I'm going to write q as 3 upon 4 raised to r. R is 9. So you can quickly take the calculator and write the answer. So that's 3 divided by 4 to the power 9. That gives you 3 upon 4, this whole raised to 9. So the answer has come 0.075084 and so on. So I'll write my answer as 0.07508 can be written as 1. 0.0751 is the answer for part B. Students, now it's time for us to move on to the next question. In the second question, students, we have a summary of 40 values of x gives the following information. Summation of x minus k is 520. Summation of x minus k the whole square is 9640, where k is a constant. The first part of the question is, given that the mean of these 40 values of x is 34, find the value of k for 2 marks. Second part is find the variance of these 40 values of x. Okay, that's for another 2 marks. So you have these two sub questions. Let's begin. Let's first of all understand the question. The question is from what? So the question is basically saying that summary of 40 values of x gives the following information. Summation of x minus k. You want to find the mean and the variance. So it is nothing but what? So this topic is from measures of central tendency, right? So we have this topic where you want to find the central values and the measures of dispersion of those central values. So the question goes like this. Summation of x minus k is given to us as 520. Summation of x minus k the whole square is given to us as 9640. The mean of those 40 values is 34. Find the value of k. So that's an easy part, students. You must recall these few things that you have learned. So there was one topic called as coding. Okay, what does it say? So it says like this. If x1, x2, x3 and so on up to xn are n number of variates. Okay, x1, x2, x3 up to xn are n number of variates or observations or scores, let's say. So do you know that x bar, the mean, is given by summation of xi divided by the number of observations? Now, if you increase or decrease every individual observation by a certain amount, if you're increasing x1, x2, x3 up to xn or decreasing x1, x2, x3 up to xn by a certain amount, let that amount is k. So the mean also gets increased or decreased by the exact same amount. So if the new values, if the new observations are like x1 plus k, x2 plus k, x3 plus k, and so on up to xn plus k, then the mean of these new observations is also going to be increased by k. So the new mean is going to be x bar plus k. And same goes with if you're going to subtract by a certain amount. So x1 minus k, x2 minus k, and so on. Then the mean will also get reduced by k. So the new mean would be x bar minus k. This is true for multiplication as well as division also. If every variant, every score is getting multiplied by a certain factor, let's say k, then the mean also gets multiplied by k. And if you're going to divide every element, every observation, every score by a certain value k, then the mean also gets divided by k. So now if I say that every variant is reduced by an amount of k, so what's the mean of these 40 values given to us? It's 34, right? The mean of the 40 values of x is 34. So x bar is 34. X bar is 34. So now if every individual score is decreased by an amount of k, x minus k, so therefore I can have x1 minus k, x2 minus k, x3 minus k, and so on up to xn minus k. So we have 40 values like this, right? So the new mean will also get decreased by the amount k. So therefore I can say the mean of these observations, the mean of these observations is going to be how much? Is going to be x bar minus k, right? That is 34 minus k, because we knew that x bar was how much? We knew that x bar was 34, right? So the mean of these observations is going to be 34 minus k. So let us say that this xi minus k is represented as capital X. Okay, I'm going to represent this xi minus k as capital X. So therefore I can say capital X bar is going to be small x bar minus k, or I say 34 minus k. But we know x bar, capital X bar is going to be summation of xi divided by number of observations. So that's summation of x minus k, right? Or xi minus k whole divided by the number of observations. So what is summation of xi minus k given to us? Summation of xi minus k is 520. So I write here 520 divided by the number of observations. So the number of observations is 40. That gives me 13, right? So capital X bar is 13. Capital X bar is 13. And capital X bar is also 34 minus k. Capital X bar is also 34 minus k. So can I say 13 is equal to 34 minus k? I can simplify for k. So minus k will transfer on the left and 13 goes on the right. So what's the value of k here, students? So k is going to be 34 minus 13, or I can say the value of k is 21. That's my answer, right? K is equal to what? 21. So that's the solution for the first part. So again, this much information is not needed. Okay, you might just skip few of the steps. You can simply write that summation of xi minus k divided by n is going to be equal to 34 minus k, and simply get the value of k. So I have given the detailed explanation of what goes into the concept of the question. So that was part A. Let's proceed for part B now. So again, the concept of coding is needed. So you want to find the variance of these 40 values of x. You want to find the variance of the 40 values of x. Now try and understand, students. So according to the coding concept that we have learned, if you have variates x1, x2, x3, and so on up to xn, then if the mean is denoted by x bar, every individual score gets added or subtracted by k, added or subtracted by k, then the mean also gets added or subtracted by the same amount. But students, the standard deviation does not change. The standard deviation does not change. It remains the same. Sigma x and sigma capital X is equal. Okay, that means capital X is what? Capital X is xi, or capital Xi is xi plus or minus k. So remember this, if you increase or decrease the individual scores by a certain amount, then the standard deviation still remains the same for both the variables, the original variable and the changed variable. But if you multiply every individual score by a certain amount, if you multiply by an individual every individual score by a certain amount, then the standard deviation also gets multiplied by the same amount. And if you divide by a certain amount, then the standard deviation also gets divided by the same amount. And if the standard deviation gets multiplied by k, then the variance will get multiplied by k square. Or if the standard deviation gets divided by k, then the variance gets divided by k square. You want to understand this concept very properly over here. So in our question, multiplication division is not involved, addition subtraction is involved, right? So the standard deviation for x and the standard deviation for x minus k remains the same. Got it, students? The standard deviation for x and the standard deviation for x minus k remains the same. So I can write here sigma x, and sigma x is equal to sigma x minus k, or I write sigma of capital X, where I'm going to write capital X as x minus k. Now, this is for sigma x. Then what will happen for the variance? So therefore, variance, that is v of x, will be equal to v of x minus k, or I write v of capital X. The variance is going to be exactly same. Now, do you recall what's the formula for variance, students? There are two different formulas for finding the variance. The first one is summation of xi minus x bar the whole square, whole divided by n. Try and understand, it is not xi minus x bar the whole square divided by n. It's the summation of xi minus x bar the whole square divided by n. So you want to first find the summation of the squares of the deviations, and that gets divided by n. Or you can also have another formula. The other formula goes like this: 1 upon n summation of xi square minus x bar the whole square. So either of the two formulas can be utilized. If you have the deviation straight away, use the first formula. If you do not have the deviations, use the second formula. Okay, so most of the time the second formula is given a preference to solve questions. So that's the formula for v of x. Now students, if that's a formula for v of x, what will be the formula for v of x minus k? So I can say, and I know that v of x and v of x minus k is exactly going to be same, because the standard deviation remains the same if every individual score gets added or subtracted by a certain amount. Only it will change if the individual scores are multiplied or divided by a certain factor. Okay, so v of x and v of x minus k is going to be same. So using this formula that you have learned just now, can you figure out the formula for v of x minus k? So the formula would go like this. So v of x minus k is going to be what? I'm going to make use of the second formula, students. As I said, usually we make use of the second formula. Okay, and you will come to know why the second formula can be used over here. So if you just simply replace x by x minus k, what will happen? So the formula goes like this: 1 over n summation of. So you had xi square. That means you want to do the square of the variate. Your variate is x minus k. So I'll write here xi minus k the whole square, right? Minus, so xi minus k is what? Capital X. So you can write it as capital X bar square, or you can simply say it is x bar minus k the whole square. It's one and the same thing, students. Xi minus k is capital X. So the formula goes like this: v of capital X is actually 1 over n summation of x square minus x bar square, right? And what is this x? X is x minus k. So I can have this 1 over number of observations is 40 is summation of xi minus k the whole square given to us. Look at this. Summation of xi minus k the whole square is given to us as 9640. So I write here 9640 minus what's x bar? Capital X bar. So that is also obtained here. Capital X bar was 13. So I go here and I write 13 square. Now my job is to just simplify this. So I'm going to go to the calculator. It's 9640 divided by 40. Okay. And then minus 13 square. So the answer comes 72. So V of X is 72. If standard deviation is asked, you just want to take the square root of the variance. Don't you all know that V of X is sigma square, right? So if you are asked to find the standard deviation, then you simply take the square root of the variance that you have got. So that was the second part of the question. Isn't it an easy question, students? So V of X I've got as 72. So you need to know the concept of coding very properly over here. So that is how we have completed the first question. Students, now it's time for us to move on to the not the first question, that was the second question. Sorry for that. That was a second question, right? So now we are going to move ahead with the third question. So again, third question, what does the question belong to? The question goes like this. For her bedtime drink, Suki has either chocolate, tea, or milk with probabilities 0.45, 0.35, and 0.2. So the probabilities are given to us, right? For her bedtime, Suki will have either of the three drinks which are given over there. So the probabilities for those drinks are given 0.45, 0.35, and 0.8. Now, can you observe that these events of either having a chocolate or a tea or milk is they are all mutually exclusive events. She does not have both of the things together, right? She will not have a chocolate and the tea together, or tea and milk together, or milk and chocolate together. See the probability 0.45 plus 0.35, that will give you 0.8 plus 0.2, that gives you perfect 1. That means the three events which are given here are definitely mutually exclusive. Only one of them is going to happen. Now further it is said that when she has chocolate, the probability that she has a biscuit is 0.3. So along with the chocolate, she also has a biscuit. That probability is 0.3. And if she's taking tea, then the probability of having biscuit is 0.6. And if she's having milk, then she never has a biscuit. That means probability of having a biscuit when she takes milk is 0, right? Find the probability that Suki has tea given that she does not have a biscuit. Try and understand the question very carefully. The probabilities are given for having the biscuit with that particular drink or the chocolate. And the question says that you find the probability that Suki has tea, she has taken tea, given that she does not have a biscuit. So she has not taken the biscuit, right? She has not taken the biscuit. And you want to find the probability that when she has not taken the biscuit, what is the chance that she has taken a tea? So this is a reverse situation question, students. So there is a concept called as the Bayes theorem, but we are not going to solve the question by Bayes theorem because your syllabus does not contain Bayes theorem. Okay, so we're going to solve this question by the usual technique of probability. So the question definitely belongs to probability, isn't it? That part has been understood by you. We have to just go ahead and solve the question now. So the three events are the event of having a chocolate or tea or milk are what? They are mutually exclusive. So only one of them is going to happen. So I'm going to draw a tree diagram over here. Okay, so probability tree diagram has to be made over here. So Suki has either a chocolate. So I'm going to call that event as, say, B1. Okay, so B1 is having chocolate. So what's the probability of B1 given to you? It's 0.45, right? That's the first branch. Let's take the second branch now. So the second branch says she will have tea. So that's B2. Suki takes tea. What's the probability of B2? That's 0.35, right? And then we take the third event. So here it is, I'm going to take it as B3. She takes what? Milk, right? Suki takes milk. What's the probability of having milk? It's 0.2. Now, after these events are going to happen, what's the next subsequent event? she eats or does not eat. She eats or does not eat a biscuit, right? So after B1, so if she takes chocolate, then what's the probability of having a biscuit? If she takes tea, what's the probability of having a biscuit? If she takes milk, what's the probability of having a biscuit? So what's the subsequent event that is happening after every BI? BI is B1, B2, and B3. So she takes or she has a biscuit. That is what is happening. So I can write over here. I can write over here. A is a subsequent event. Okay. Maybe I can call it A as a subsequent event, which says that she takes a biscuit. But when I read the question does not say what is the probability that Suki has tea given that she has taken a biscuit, right? That's not the case. You want to find the probability that Suki has tea given that she does not have a biscuit. So the question is of what? It is of conditional probability. So we already know that she has not eaten the biscuit. What's the probability that she must have taken tea? So I'm going to write event A as what? Event A is she does not have a biscuit. Suki does not have a biscuit. So what's probability of A under B1? So A under B1 means what? So she has eaten a chocolate. What's the probability that after eating a chocolate, she also has a biscuit? So that probability is given to us as how much? That probability is 0.3, right? So probability of chocolate under, or I should not write like this. I should write probability of biscuit under chocolate. So she has already eaten a chocolate. Now she's going to eat a biscuit. The probability is how much? The probability is 0.3. So what's the probability that she has taken a chocolate, but she has not eaten the biscuit? Will it be 0.7? So I'm going to write here 0.7, right? Probability of A under B1. A under B1 means what? Suki has taken the chocolate, but she has not taken the biscuit. So A under B1. So that's 0.7. Can you now also tell me what would be the probability over here? So A is still same. Suki does not have a biscuit, but this time probability of A under B2 is going to come, right? So Suki is not having the biscuit, but she has already taken tea. So you know that when she has tea, the probability that she will have a biscuit is 0.6, right? Then what's the probability that she has taken a tea, but she has not taken biscuit? It will be 0.4. So probability of A under B2 is 0.4, right? And the third case is again, event A is happening. She is not taking a biscuit. A is an event. Suki is not eating a biscuit. So what's the probability there? So P of A under B3. So when she has taken milk, what's the probability of having a biscuit? She never has a biscuit. So this probability is 0. So probability of having a biscuit when she has taken milk is 0. So what's the probability of not having a biscuit? So she never has a biscuit, right? That means probability of having a biscuit when she has taken milk is 0. Then probability of not having a biscuit is going to be 1, right? Probability of having a biscuit. She never has a biscuit means what? If I say if Suki takes milk, okay, she's going to take milk. Then what's the probability of having a biscuit? Having a biscuit is 0, right? Having a biscuit is 0 because she never has a biscuit. So probability of A under B3 is going to be what? She does not have a biscuit is 1, right? Having a biscuit is 0, not having a biscuit is going to be 1. So that's how the probability tree diagram is going to look like. So I want to find the probability that Suki has tea given that she does not have a biscuit. So I want to find the probability of what? Probability of I already know that she has not taken a biscuit, right? So under A, she has not taken a biscuit. What's the probability that she has taken? She has taken T. So for T, it is B2. So I want to find probability of B2 under A. So probability of B2 under A, it will be what? The formula according to the conditional probability P of A under B is N of A intersection B upon N of B, or I can simply write as probability of A intersection B divided by P of B. So probability of A intersection B means what? So here I'm going to write the formula as probability of B2 under A divided by probability of A. So what do you mean by probability of A? Probability of A means what? Suki is not having a biscuit. So Suki is not having a biscuit and she had a chocolate, or Suki is not having a biscuit and she had tea, or Suki is not having a biscuit or she had milk. So P of A is going to be what here? So probability of A is going to be 0.7. Suki is not having a biscuit and she had a chocolate. So 0.7 multiplies with 0.45, right, students? Or I can say, or so that's plus, isn't it? She's not having a biscuit and she had tea. So that's 0.4 multiplies with 0.35, or she's not having a biscuit and she had milk. So 0.2. So I'm going to get what here? So it's 0.7 multiplies with 0.45. Take a calculator, start solving it. 0.4 multiplies with 0.35 plus 1 times of 0.2. So I just add 0.2. The answer is 131 upon 200. 131 upon 200, which comes out to be 0.655. So that's the probability of not having a biscuit. Now, B2 intersection A, that means what? She had a chocolate, not chocolate, what? B2 is for tea, sorry. So she had tea and she does not have a biscuit. So it's probability of B2 intersection A. So that's probability of B2 times probability of A. So what do I get here? What is probability of B2? So it is 0.35. 0.35 multiplied with what is probability of A? So probability of A means what here? So this is A under B2, right? I'll better write it over here, not just P of A. I'll write here probability of A under B2. So that probability is 0.4, right, students? 0.3. So because B2 intersection A is happening. B2 intersection A means what? So she has to take tea and then she will be taking a biscuit. So probability of A will be from second category, the second branch that we have. So that's 0.4 here, 0.4. So that should give me 0.35 multiplies with 0.4. That's 7 over 50. 7 over 50, or I write 0.14. 0.14. So now I'm in a position to find the probability of B2 under A, right? Probability of B2 under A. So that's going to be 0.14, which is probability of B2 intersection A divided by P of A, which is 0.655. 0.655. So 0.14 divided by 0.655. The answer has come 28 over 131. Or you can write the answer as 0.21374. 374. So I'm going to write three significant figures. So 28 upon 131, or I write 0.214, right? So that's how the question ends. So I'm pretty confident, students, that this question is well understood by you, right? So that was your question number 3, a simple question, right? So you need to know the concept very properly. So question number 3 is done. We now go to question number 4. Okay. Now what's said over here? What's given to us? The question says a fair spinner has edges numbered 0, 1, 2, 2. So we have a spinner and its edges are numbered as 0, 1, 2, 2. So I'm quickly going to draw a simple diagram. Let's say that's a spinner. Okay. I'll draw one more spinner because there is another fair spinner. So there are two spinners given to us, and that edges, and for that spinner, the edges are numbered as -1, 0, and 1. So I will divide this spinner, the first one, into 4 parts. Okay, because there are 4 numbers given to us. So let's divide this into 4 parts. The first spinner is divided into 4 parts. It is 0, 1, 2, 2. So I'll just write the numbers very quickly over here. That's 0, 1, 2, 2. So 0, 1, 2, and 2. So I've given clockwise rotation 0, 1, 2, 2. And now for the second one, I need to divide it into how many parts? 3 parts, -1, 0, and 1. So I just divided it into 3 parts. So that's how I'm going to divide it. Okay. So the numbers that I need to put here are -1, 0, and 1. And now I'm going to spin them. Okay. So let's say this is the pointer over here. It is going to point towards a number. Okay. That's a pointer. That's the pointer which is going to point towards a number. Fine. Now what's the question? The question says each spinner is spun. The number on the edge on which a spinner comes to rest is noted. Okay, so you give spin, okay, to both the spinners, and the arrows are in the arrows over there are telling you what. So the arrows given to you are going to indicate the number. Okay. The random variable x, random variable, okay, x is the sum of the numbers for the 2 spinners. So you're going to add those 2 numbers. Okay. Draw the probability distribution table for x. So the question is definitely of probability distribution. That's the first part. And the second part, find variance of x. No third part is there. So again, 2 parts, fairly simple question. So start thinking about this. So on the first spinner, you might get a 0, right? On the first spinner, you might get a 0. And on the second spinner, you might get a -1 or a 0 or a 1. So you want to find the sum. X is what? X is the sum of the numbers for the 2 spinners, right? X is the sum of the numbers. So x can be, so 0 and -1. You want to add it, so you can get a -1. 0 and 0, you get a 0. 0 plus 1, you get a +1, right? So you might get x as what? -1, 0, or 1. If you have 1 on the first spinner shows 1. The second spinner might show -1. So the sum is what? 1 minus 1. So that's 0, right? Then 1 and 0, that's 1. The sum is 1. And 1 and 1, the sum is 2. So the value of x can be -1, 0, 1, and 2. Up till now, we have got 4 different numbers that x can have the values as -1, 0, 1, and 2. The next one is what? The next number is 2, right? And the next number is again 2. So for both of them, the value of x is going to be same. So that's 2 minus 1, which is 1, right? 2 plus 0, that's 2, and 2 plus 1, that's 3. So the value of x is going to be what? So x can take values, x can have values -1, 0, 1, 2, or 3. Did you get that, students? How the value of x is obtained? What is x here? X is nothing but the sum of the numbers for the 2 spinners. So you are going to spin both the spinners, right? And you want to note the number. So on the first spinner, you might get a 0. And on the second spinner, you might get a -1 or a 0 or a 1, and so on. So I have noted down the sum. So it is -1, 0, 1, 2, or 3. Drop the probability distribution table for x. Now you tell me, when is it possible to get a -1? So do you recall this -1 is possible when you get 0 on the first spinner and a -1 on the second spinner, right? So probability of x equal to -1 is what I want to find. Probability of x equal to -1. So on the first spinner, you get a 0 and on the second spinner, you get a -1. So first spinner, you get a -1, and second spinner, I get a, sorry, on the first spinner, you are going to get what, students? Really sorry for that. On the first spinner, you are going to get 0, and on the second spinner, you are going to get -1, right? 0 and -1. So what's the probability of getting a 0 on the first spinner? So there is only 1 0 on the first spinner and total 4 outcomes. So I get my probability as 1/4, and is multiplication. Now on the second spinner, you're going to get -1. There's only one outcome which says -1, and total 3 outcomes are there. So that's 1/3. I hope you have understood, right? So the spinner is going to show -1. How many -1s are there? Only one -1 is there. Only one outcome is the favorable outcome. -1 is my favorable outcome. There's only one -1, and total 3 outcomes are there. That's why 1/3. So the probability of x equal to -1 is 1/12, right? Let's get probability of x equal to now what? The next number was 0, right? So probability of x equal to 0. You've got to be very careful now. So probability of x equal to 0. So I'm going to get 0, right? So it will be 0 from the first spinner, 0 from the second spinner, right? 0 and 0. So the outcomes were like this. It was 0, -1, right? 0, 0, and then 0, 1. Then it was 1, -1, 1, 0, and 1, 1. Then it was 2, -1, 2, 0, and 2, 1 again. 2, -1, 2, 0, and 2, 1. So you want to get x equal to 0. Some should come 0. This is where the 0 can come, right? 0, 0. This is where 0 can come, and 1, -1 also can give you 0. Are you getting it? So you can observe. So there is another way also to get this answer. So these are the total number of outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 outcomes are there. And out of these 12 outcomes, how many outcomes are there where you might get a 0? So that's 0, 0, and 1, -1. There are 2 outcomes. So 2 divided by 12 is what you can write over here directly. The answer is 2 divided by 12. Or students, to get x equal to 0 from the first spinner, you might get a 0. And from the second spinner, you should be getting another 0. So that's 1/4 into 1/3, or 1/4 into 1/3, right? 1/4 into 1/3. From the first spinner, you get a 0. From the second spinner, you also get a 0. 1/4 is the probability of getting a 0 in the first spinner. 1/3 is the probability of getting a 0 from the second spinner. Or, so I write a plus, you get a 1 and a -1. 1 from the first spinner, -1 from the second spinner. So it's again 1/4 and 1/3. So it's again going to be 1/4 multiplied with 1/3. So that's 1/12 plus 1/12. You can say 2/12. So either you can have all these outcomes together and then quickly write the answers, or you can go the other way around as well. You can observe in this case also, what can you say? X equal to -1, right? So sum has to come -1. It is possible only in this outcome, 0, -1. That is the only outcome where you can get the sum as -1. So it's going to be 1/12. Total outcomes are 12, isn't it? Now, that was probability of x equal to 0. Now let's take probability of x equal to 1. Probability of x equal to 1. So getting 1, the sum has to come 1. So start identifying where can you get the sum as 1. Is it here, 0, 1? The answer is yes. You can get 1 over here. What about this 1, 0? Yes, the answer is right. 1 plus 0 is again going to be 1. What about 2 minus 1 and 2 minus 1? Will you get the sum as 1 here as well? Right? 2 minus 1 is going to be 1. 2 minus 1 is going to be 1. Any other possibility that you can see over here? So total 4 outcomes are there, right? Total 4 outcomes are there where you might get the sum as 1, and total number of outcomes, possible outcomes, is 12. So the answer is 4/12, right? So I'm going to be quick now. Probability of x equal to 2. So now you should get the sum as 2, right? So let's take a different color now. So x equal to, you want to get 2, right? X equal to 2. Is this the possibility where you might get 2? 1 plus 1, that's 2. What about 2, 0? The answer is yes. You again get a 2. What about this 2 comma 0? The answer is yes. Again, you get the sum as 2. So there are total 3 outcomes where you can get the sum as 2. So I write 3 over 12. And finally, I'm going to get probability of x equal to 3. So I'm going to get 3 now, right? So let's take a different color this time. So for 3, what do I have? I have 2 comma 1 and 2 comma 1. There is 2 different possibilities where I can have a 3. So that's 2 over 12. So let's quickly add them up. Let's see, it's a probability distribution table that I want to make, right? So the sum of the probabilities need to come 1. So 1 over 12, 2 over 12, isn't it? So this 1 over 12, 2 over 12, 4, then 3, then 2. You want to sum them up. That's 1 plus 2. Everybody has denominator 12. So you just want to add up the numerator. So 1 plus 2, that's 3, 3 plus 4, that's 7, 7 plus 3, that's 10, 10 plus 2, that's 12. So that is absolutely correct answer, right, students? I hope that the question is understood. Now you just want to make a table, okay? So you want to definitely construct a table now. Let's quickly make a table here. So I'm going to write x, okay? Let's create a table very quickly. I'm going to write x. So let's duplicate this and keep on placing it at some distance. We have the values as what? -1, 0, 1, 2, and 3. So I need 1, 2, 3, 4, 5 columns. So again, duplicate it. Let's duplicate it. And one more column. That's the last column that is needed. Okay. And then it's good to make proper diagram for the table as well. Okay. So what is x here? What's the random variable? It is the sum, right, of the numbers for the 2 spinners. So x is sum of numbers of 2 spinners. So that was -1, 0, 1, 2, and 3. And what's the probability of x that you have got? So for -1, it was 1 over 12. So I write here 1 over 12. Then it was 2 over 12, right? Then we had 4 over 12 for x equal to 1. Then we had 3 over 12 and 2 upon 12. So that's how the distribution table must be shown for the given question. So what I'm going to do quickly here is I'm going to shade my answer. Okay, that's my answer, students. So that's how you can complete this particular question. Okay, so that was 4th question. Let's proceed ahead for the next question. Yeah, there is part B as well. I have to find the variance. That is again very simple. I hope you already know the formula for variance of x, v of x. Isn't it e of x square minus e of x, the whole square, right? So I want to get e of x and e of x square first of all. So e of x is given by summation of xi into the probabilities of xi, right? So let's go back to the table very quickly. So xi was what? -1, 0, 1, 2, 3, right? And the probabilities are 1 over 12, 2 over 12, and so on. So you simply want to multiply them. So -1 multiplies with 1 upon 12 plus 0 multiplies with 2 upon 12 plus 1 multiplies with 4 upon 12 plus 2 multiplies with 3 upon 12 and 3 multiplies with 2 upon 12. So the answer is going to be what? So the first answer is -1 over 12. -1 multiplies with 1 upon 12 is -1 upon 12. So -1 divided by 12. The next value is plus 0 times of 2 upon 12. So that's just 0. Plus the next answer is 4 upon 12. The next answer is 6 upon 12, right? 2 times of 3, 6 upon 12 plus. The next answer is again 6 upon 12. So the answer comes 5 upon 4. Okay, so that's the value of e of x. So I'll write here 5 upon 4. Let's quickly get the value of e of x square also. So that's going to be summation of xi square into the probabilities of xi. So that's going to be minus 1 square multiplied with 1 upon 12, right? Xi square is like squares of the values of the random variable. So minus 1 upon square into the probabilities, 1 upon 12 plus 0 square into 2 upon 12 plus 1 square multiplied with 4 upon 12 plus 2 square multiplied with 3 upon 12 plus 3 square multiplied with 2 upon 12. So let's quickly get this answer as well. So it's like minus 1 square multiplied with 1 upon 12. It's still 1 upon 12, right? Again, 0 multiplies with anything, it's going to be 0 plus 1 square is like 1 multiplied with 4 upon 12. So 4 divided by 12 plus 2 square is 4. 4 into 3, that's 12 upon 12, which is going to be 1. And 3 square is 9. 9 times 2, that's 18 divided by 12. So my answer comes 35 over 12. So that's E of x square. 35 over 12. So I can now get the value of V of x. It was E of x square minus E of x the whole square. So 35 upon 12 minus, it was 5 upon 4 E of x the whole square. So that should give you what? So 35 upon 12 minus 5 divided by 4 the whole square. That comes out to be 65 upon 48. Or I can write, so if I want to write in decimals, it's 1.354167. So 1.354167, but I want to write up to what? 3 significant figures, right? So the answer is 1.35. So I'll just quickly shade the answer. It's V of x. So either you can mark this as the answer or you can mark this as the answer. Okay, so full marks for the answers which are written. So it's better to write the fraction 65 upon 48 and the 3 significant figures. The instructions clearly indicated that you want to write the answers up to 3 significant figures. That was question number 4. It's time for us to move on to the next question, which is question number 5. Now, what does 5 say? Raman and Sanjay are members of a quiz team which has 9 members in total. So 9 members in total means Raman and Sanjay are the part of that 9-membered team. Okay, so that's like inclusion. Raman and Sanjay are included in those 9 members. It's not like 9 plus Raman and Sanjay. It's total 9. 2 photographs of the quiz team are to be taken. So to take 2 different pictures of this entire team. For the first photograph, the 9 members will stand in a line. So all the 9 members are standing in a line. Okay. How many different arrangements of the 9 members are possible in which Raman will be at the center of the line? So it's a very simple question, right? So everybody wants to stand in a line. All the 9 people are going to stand in a line. But where does Raman stand? Raman exactly stands in the center. Okay, Raman is going to stand exactly in the center, right? So there is only one place available for Raman. That place is in the center. One place and only one member to be arranged in that one place, and that's Raman. So Raman can be arranged in 1P one way. Arrangement is happening, students. So this is a question on permutations and combinations, right? So whenever you're doing arrangements, it is permutation. Whenever you're going to do selection, that will be combinations. You are arranging the objects over here. So how many different arrangements of 9 members are possible in which Raman always is in the center of the line? So Raman can be arranged in only one way. Okay, so that's the center place. So 1P1 is the way in which Raman can be arranged. Now the remaining 8 places. So that's 1, 2, 3, and 4. 1, 2, 3, and 4. So total 8 places are left and 8 members are left, isn't it? So 8 members and 8 places. So these can be arranged in 8P 8 ways, right? The remaining 8 members can be arranged in 8P 8 ways. Got it? So I can write the answer something like this. So total arrangements. It is going to be, let's arrange Raman first of all, 1P one way, multiplied with. Now you arrange the remaining 8 places with 8P 8 ways. So that's going to be 8 factorial because 1P1 is 1, right? 1 factorial is 1. And then you have 8P 8, that is 8 factorial. So what's the answer for 8 factorial? It's 40320. So it's simply 40320. So 40,320 different arrangements can be there when Raman comes in the center place and the remaining 8 players are on either side of Raman. So that's the first part, 1 mark question. How many different arrangements of the 9 members are possible in which Raman and Sanjay are not next to each other? Very important question, students. Try and understand this question very carefully. Now, you don't want Raman and Sanjay to stand next to each other. So they should always be separated from each other, right? So Raman and Sanjay should be always separated. The best way to do this, to separate the two people, is to place a third object between these two, right? If you want to separate two objects, what you do is you place the third object in between these two objects. So let's do this one thing over here. Let's ask Raman and Sanjay to stand aside for some time. We will do their arrangement a little later. Okay. Since I don't want Raman and Sanjay to come next to each other, so I'll ask them for some time to stand away from the arrangement. Let's do the arrangement of the remaining people, because remaining people can stand anywhere that they want. Okay. There is no condition that is imposed on the remaining 7 members. So what I do is I do the arrangement of the 7 members first. So I have these 7 members like this. Maybe I can draw the diagram. So that's 1, 2, 3, 4, 5, 6, and 7 members. Okay. So let's do the arrangement of 7 members first. So 7 members can be arranged in 7p7 ways. That's 7 factorial ways, right, students? Once these 7 members are arranged, what we can do further is now we will call Raman and Sanjay and ask them to stand in between these blank spaces that you can see. So that's 1, 2, 3, 4, 5, 6, 7, and 8. Can you understand? These are the 8 different places available. So 1, 2, 3, 4, 5, 6, 7, 8. 8 places are available where Raman and Sanjay can stand and they will not be next to each other. Even if, let's say, Raman stands here and Sanjay stands in this particular place, or they can also reverse their positions. So out of these 8 places, any 2 places can be occupied by the 2 objects, right? Now, of course, the interchanged conditions are also taken into account when you're going to arrange these 8 objects, right? 8 places with the 2 objects. So 7 members can be arranged in, first of all, 7p7 ways, which is 7 factorial ways. Now, I have asked these 7 people to stand in such a way that they maintain 1 space in between them. Then I call Raman and Sanjay and ask them to stand anywhere in the 8 places total available, right? Any 2 places will be occupied by the 2 objects, Raman and Sanjay. So therefore, I can say the remaining 8 places now, not the remaining, the total 8 places now can be occupied by the 2 objects. This can be done in how many ways? So 2 members can be arranged in 8 places. In how many ways? That's 8p2 ways, isn't it? So that's 8 factorial divided by 8 minus 2, which is 6 factorial, right? So the first thing done was the arrangement of the 7 members. The second thing done was the arrangement of the 2 members in the 8 places. That means according to fundamental principle of counting. So when I say ATFPC, that's a short form that I'm using for fundamental principle of counting. So according to the fundamental principle of counting, total arrangements would become equal to what? Total arrangements is going to be, so the first thing was done in 7 factorial ways. So I write 7 factorial multiplied with, the second thing was done in 8 factorial divided by 6 factorial. So the answer is going to be what? So this 7 factorial can be written as 7 times 6 factorial. 6 factorial, 6 factorial cancel. So you simply want to get 8 factorial multiplied with 7, right? 8 factorial multiplied with 7. So the answer is 282,240. 282,240. That's 282,000 and 240s. Okay, so 282,240 are the total number of ways in which you can arrange in such a way that Raman and Sanjay are never standing next to each other. So that's one way of getting the answer. Students, there can be another way also. What you do is you arrange all the 9 members together. First of all, arrange all of the 9 members. So 9 members can be arranged in 9p9 ways. That's 9 factorial ways, right? Total arrangements of all the 9 objects. Then you subtract those arrangements where Raman and Sanjay are standing together, right? Raman and Sanjay are both standing together. So together means one object, okay, and then total 7 objects are left. Total 9 objects were there. Out of 9 objects, call Raman and Sanjay out, keep them together now. So remaining objects are 7, and this Raman and Sanjay together is one object. So 7 plus 1, that's 8 objects. 8 objects can be arranged in 8 factorial ways, right? 8 objects. So 7 members and 1 object of Raman and Sanjay. So total 8 objects. They can be arranged in 8p8. That is 8 factorial ways. And Raman and Sanjay can switch their places. They can interchange. So they can be arranged among themselves. That can be done in 2 factorial ways. The answer should come exactly same. So any of the methods you want, you can apply. So I'm going to get the answer over here as well. So 9 factorial minus 8 factorial multiplies with 2 factorial, that's just 2. So the answer comes what? It is still 282,240. 282,240. So students, either of the methods can be utilized to get the answer, right? But my favorite method is the first one. Okay, you ask Raman and Sanjay to stand aside, arrange all the objects first, and then call them and ask them to stand in any of the remaining places, the places which are now generated by the 7 people. So 8 places gets generated, 2 objects need to be arranged. So I can have my answer this or by this method. Okay, so that was all about question number 5. Is there any other sub question? Yeah, there is another sub question also. There is part C and D now. Okay, the second part of the question, the second photograph needs to be taken. This was the first photograph, right? This was the first photograph. Now you want to take the second photograph. In the second part now, what is he asking? So for the second photograph, the members will stand in 2 rows with 5 in the back row and 4 in the front row. So I'll need to have 5 people in the back row. So that's 1, 2, 3, 4, and 5. So that's the back row, and 4 people in the front row. So I'll make them to stand like this. This is the front row. Now, what does the question say? In how many different ways can the 9 members be divided into a group of 5 and a group of 4? So try and understand, students. This question, does it belong to permutation or does it belong to combination? In the first part that you have solved, can you see the question says how many different arrangements? How many different arrangements? So when the question contains the word arrangements, it is definitely a question on what? It's a question on permutation, right? Now let's try and understand this C part of the question. In how many different ways can the 9 members be divided? I just want to divide them. I do not want to make them stand in a row. If I ask them to stand in a row, then I'm doing arrangement. Then the question is definitely of permutation. But what I'm doing here, I'm just asking the members to get divided into a group of 5 and a group of 4 people. So how do I do this? So I am doing selection, right, students? Out of the 9 members, I first make the first group of 5 people, and then I make the group of 4 people. So I'm just going to do selection here. So this question is of selection. That means it's a question of combination. You really want to understand this part very properly. So in how many different ways can 9 members be divided? Okay, this word that you see here, can be divided, tells you that the question is not of arrangement, it is a question of selection. So now that's pretty simple, right? So what I'm going to do here is I'm going to just select 5 people out of 9 people, right? So there are 9 members available, of which I'm going to select 5 people. So I can say total arrangements or total selections. total selections of 5 members out of 9 members. It can be done in 9C5 ways, right? So 9C5 should give you 9 factorial divided by 5 factorial. 9 minus 5, that is 4 factorial. I hope you all know the formula of NCR. That's n factorial divided by r factorial, n minus r factorial. So you should know the formula. Although you have this 9C5 that can be evaluated directly from the calculator. So write 9C5. So that gives you 126. So that's 126. So that was selection of 5 people out of 9 people. Now there are still 4 people to be selected from the remaining 4 people. So for remaining 4 members, I can do the selection in 4C4, which simply comes 1. So according to fundamental principle of counting, the first thing that was done was a selection of 5 members from the 9 members. It was done in 126 ways. And then the selection of 4 members, or you can simply say the 4 members which are left are the second group. So that can be done in 4C4, which is 1. So the final answer comes 126. So total selections is 126. That's the answer for the part C. Now let's quickly go to part D. So for a random division into a group of 5 and a group of 4, find the probability that Raman and Sanjay are in the same group as each other. So try and understand. Either Raman and Sanjay are in the group of 5 or they are in the group of 4. So the question is very tricky over here. Try and understand the things very carefully. So first of all, what are the total number of selections that might happen if you are going to divide into group of 5 and group of 4? So that's 126, right? Total selections is 126. That's your trial. You are dividing 9 members into group of 5 and group of 4. That's your trial. Now, what is your requirement? What is your desired outcome that you want? You want Raman and Sanjay to be either in the group of 5 together or in the group of 4. It should not be like Raman is in one group and Sanjay is in one group, right? Both of them should be in the same group. That is your desired outcome. That's your event. So here trial is what? So trial or the random experiment is 9 members are divided in groups of 5 and 4, right? So therefore, what is n of s? It is going to be 126. It is already evaluated over here. Okay, we are just going to make use of that answer. Now, what's your event? So event is, let's say E, Raman and Sanjay are in the group of 5, or Raman and Sanjay are in the group of 4, right? So what is n of E? Let's try and analyze this thing very properly. Raman and Sanjay are in the group of 5. So I want to select 5 people. Okay, out of 9, I want to select 5 people. But in this 5 people, Raman and Sanjay definitely should be included. In this 5 people, Raman and Sanjay are already there. This is called as particular inclusion. So I have 9 members. I'm going to select 5 members for me. Okay. But in these 5 members, Raman and Sanjay should definitely be there, right? So Raman and Sanjay are already there. So their selection is like 2C2, isn't it? So 2C2, I'm selecting group of 5. Okay, 2C2. So 3 members are left now. Think carefully. Out of 9 members, Raman and Sanjay are called out. They are already put up in the group of 5. Now 3 places still left in group of 5. Out of 9, 2 are called, 7 are left, right? Out of 9, I've called Raman and Sanjay, so 7 are left here. Raman and Sanjay are already in the group of 5. Now the 3 places are left. I want to arrange these 3 places. I want to select 3 places, not arrange. Select 3 places out of the remaining 7 people. So Raman and Sanjay in the group of 5, 2C2 into 7C3, right? 7C3. And of course, now 7C3, that means out of the 7 people, 3 people are selected. In the group of 5, 2 are already there. So total 5 people are done. Now 4 places are left and 4 people are left. So it's 4C4, isn't it? That's one possibility when Raman and Sanjay are in the group of 5. So I will just write it over here. Raman and Sanjay are in the group of 5. Or, so or means plus, isn't it? Raman and Sanjay can be in the group of 4s. So 4 people I'm going to select now, right? They can be in the group of 4. So out of 9, I want to select 4 people, but 2 of the places are already taken by Raman and Sanjay, right? Out of the 4 places which are available in the second group, 2 places are already there, occupied by Raman and Sanjay. So again, 2C2, but now I'm arranging the group of 4. Out of 9, 2 are called out. They are put into the group of 4. 2 places still left. 7 members are there. I want to arrange this 2 places. I want to select these 2 places out of the 7 places. So I can do the selection in 7C 2 ways. And now the group of 5 is left and 5 people are left, right? Raman and Sanjay in the group of 4s. So 2 places. Again, out of 7 members left, 2 more people are selected for this group of 4. So 4 people are done. Now, how many places left? 5 places left for the second group and 5 members are there. So it can be done in 5C 5 ways. So this second arrangement is of what? This is Raman and Sanjay are in the group of 4. Raman and Sanjay are in the group of 4. So what do I get? 2C2. That's 1. 7C3. So let's quickly get using the calculator 7C3. So you have this NCR function in your calculator. You can straight away make use of it and get your answer. So that's 35. That's 35. 4C4 is going to be 1 plus again 2C2 is 1 and 7C2 this time. 7C2, that's 21 multiplied with 5C5 is 1. That's 35 plus 21. That's going to be 56. So I have got N of E as 56. So therefore, by definition of probability, I can have P of E is equal to N of E upon N of S. That's 56 divided by, you had 126, right? So 56 divided by 126, that gives you 4/9, or it is 0.4444. So you want to write 3 significant figures, 0.444. That's how we complete our question. Okay, so this is what your answer is. Fine, students. So that was your question number 5, right? So 5 part A, part B, that was for 1 plus 3, that's 4 marks. Then part C for 2 marks, that's 6 and 4, that's 10 marks. So permutation combination, students, 10 marks. Okay. Now the next topic, the next question is from the topic of, you can easily understand this is representation of data. I'll read the question for you. This is question number 6. The question says, the weights in kg of 15 rugby players in the Rebels Club and 15 soccer players in the Sharks Club are shown below. So you can observe there is a table given to us, and then there is data given for Rebels, the weights in kg for 15 rugby players, and for Sharks, 15 soccer players. Again, there are data given to us. Now you can observe that you want to represent this data by drawing a back-to-back stem and leaf diagram with Rebels on the left-hand side, and obviously Sharks will come on the right-hand side. Now, can you also observe that the data is already arranged in the ascending order? See, For rebels, it's 75, 78, 79, 80, and so on. So the data is already arranged in the ascending order. For sharks also, the data is already arranged in the ascending order. So students, you should always remember most of the questions which belong to representation of data, you will need to arrange the data in the ascending order. So I am pretty confident that you know how to make a stem and leaf diagram, right? So you know that the stem is represented at the center and the leaves come on the either sides of the stem. Now here on the left hand side, what do we need to arrange? On the left hand side, we want to arrange the rebels, and on the right hand side, we will need to arrange the sharks. So let's begin with the solution. So what I'm going to do here is, whenever you want to make a stem and leaf diagram, you always need to remember that there is a key that needs to be given while writing the solution. This is the most important part of the question. The key has to be represented. Okay, so what's the key? So now let's say I'll just make a rough work very quickly. So if this is a stem and these are the leaves, okay, these are the leaves, right? So the values which are present in the stem, let's say for rebels, you can observe it starts from 75, so that's 7, then 80, 82, that's 8, and then it goes to 93, 95, up to 102. So it's like 7, 8, 9, and 10. So the very first digit I'm taking in the stem, and then I have to represent rebels on the left hand side. So this is the left hand side, right, students? That's the left hand side. That's the right hand side, isn't it? So on the left, rebels are going to come. So the very first value is 75. So this is 7 here, and then 5 I'll write. Then there is 78. So I would write 8 here. Then there is 79. So that's 9 here. And then I get 80. So this is 8. And then this is 0. Then 82. So I write 82. So can you understand what the key is going to be represented as? So the key tells you how to read this stem and leaf diagram. Okay, so I'll put the vertical line like this. I'll write 7 over here. I write 75 like this. Okay, and then 71 like this. So can you see 71 values over here? So the key tells you how to read the stem and leaf diagram. So this is 5 with a vertical line, 7, then a vertical line, and then 1. So that's 75 kilos, 75 kilos or kgs for the rebels, and 71 kilos or kgs for the shark. So that's what the key is. Of course, I'm going to represent this in a very proper manner. So this was just an explanation. So you want to represent the stem and leaf diagram, you want to represent the key, and one more thing that you should be taking care of is always write how many values are present in one leaf. Okay, so for instance, you can see this is 75, 78, and 79. So there are 3 values over here. So represent that number, that count of how many values are present in one leaf at the end of the leaf. So that will help you to keep a tally of the data. So you know that there are 15 values which are given to us. So if you add all these numbers, you should get the total value as 15. So that way you can keep a track of your question. So I'm going to now start simplifying this question. I'm going to start making the stem and leaf diagram. Okay, so you know how it has to be represented. So there's plenty of space available. Okay, I'll just keep the data in front of me. So you should always begin with the stem. That's a vertical line. Okay, so that's a vertical line. Here you are going to represent the stem. So I'll just straighten it out a little bit. So that's the stem, and then again draw a horizontal line as well. Then you know on the left you want to represent what? So rebels on the left. So I'm going to write rebels over here. And of course, if rebels are on the left, sharks will be on the right. So you write sharks on the right. So you can see that the rebels are starting from 75 and the sharks are starting from 66. So you can start writing the stem with values like 6, 7, 8, 9, and 10, right? So you write the stem as 6, 7, 8, 9, and 10. So some extra part, whatever is there, I'm going to erase it out. Now, let's start filling of the leaves. So for rebels, it's 75, 78, 79. Okay, so there is no value which starts with 6, right? There are no 60s in rebels. It directly starts from 7. So it's 75, 78, 79. So I write 75, 78, and 79. Okay. Same way, I'll go ahead. It's 80, 82, and 83, 84, 85, 86. A lot of 8 values are there. So it's like 80. So that's 80. Now make sure that the values for the next leaf that you are going to write will come exactly below the previous leaf. So below 5, you can see I have written 0. Then there is 82. So I write 2 over here. So symmetry needs to be maintained. So again, you have 82. So again, I write 2 over here. Then I have 83. So I write 3. Then I have 84. So I write 84 over here. Then I have 85. So I write 5. And then I have 86. So I write 6. And then 89. So I write 9 over here. Okay. Now you should also understand how many values are there. So you can observe for the leaf of 7, there are 3 values. So at the end, you can write the count. There are 3 values in the first leaf. How many values in the second leaf? So that's 80, 82, 82, and so on. So that's 1, 2, 3, 4, 5, 6, 7, and 8 values. So in the bracket, you can write 8. Okay. And let's write for 9. So you can see there is 93, 95, 99. So 93, 95, and 99. One below the other is what you should be always maintaining the sequence, maintain the symmetry of the stem and leaf diagram. Okay. So there are 3 values over here. I'll just write them in a while. And then there is 102. So that's 10. And I write 2 over here. Got it? So that was for rebels. Let's very quickly write for the sharks as well. So the very first value is 66. So I write 6 and 6. Then there is 68. So I write 8. There is 71. So I write 1. 72. That's 2. 74. I write 4. 75. I write 5. Again 75. Then there is 76. 78. Then you have 83. Again 83. Then there is 84, 85, 86, and 92. Okay. Now let's quickly count the values. So this is 1, 2, and 3 values. So I write 3 over here. There's only 1 value at the end. So I write 1 over here. You can observe that the total is going to come how much? Let's very quickly get the total as well for the rebels. So you can see that the total is going to come. So that's 3 plus 8. It's going to be 11, right? 11 plus 3, that's 14 plus 1, that's 15. So there are 15 values, very rightly said. Now you can come to sharks. So there are 2 values over here. Then there is 1, 2, 3, 4, 5, 6, 7 values. So write 7 here, then 1, 2, 3, 4, 5 values. Write 5 over here. And then finally, there is only 1 value. So that's going to be what? So that's 7 plus 5. That's 12. 12 plus 2. That's 14. 14 plus 1. That's again 15. So I have 15 values at the end as well. So you can observe how I have represented the stem and leaf diagram. I'll just quickly extend this line as well. Okay, now the most important thing of all is you need to also write the key. So I'm going to write the key over here. So what's the key? So when you write the stem, let's say 7, okay, it does not matter what values are you going to write. The values might be there in the data, they might not be there in the data. It does not matter. But if you write values which are already present in the data, it becomes even more easier to understand. So when I write 7 and 5 and 7 and 1, what does it mean? So it means 75 kg for rebels. They are on the left for rebels, and 71 kg for the sharks. So that's how you represent a stem and leaf diagram. Very simple, students, right? The data was given to you. The data was already arranged in the ascending order. First point to be kept in mind that the data must always be arranged in the ascending order. The second thing that you should be taking care of is generally we take the first digit. Okay, so there were all numbers which were 2-digit numbers. Only one number was a 3-digit number. Okay, so the first number comes into the stems. Of course, when you come to 102, it will not be the first number 1. It's not just 1, it should be 10. Okay, and not 1. And then the leaves will come on the either side. Okay, the next digit that is left will be coming on the either sides. You should always try and write the total values in one leaf. Okay, that is also you want to keep in mind. And the third and the most important thing is to write the key. Students, I have seen many people not writing the key after making the stem and leaf diagram and losing 1 mark. Okay, so keep in mind that you have to write the key as well. Key has to be there in your solution, and if it is always recommended to write the total number of values in every leaf as well. So that was part A of question number 6. Let's very quickly move on to part B. Now in part B, what is asked? Find the median and the interquartile range for the rebels. So I'm pretty confident that you already know what a median is, right? So median is the exact central value of the data. And for which data the median is asked? For the rebels it is asked. Okay, so I want to find the median for the rebels and the interquartile range. So that means I need to find the quartiles. So I hope you recall that there are quartiles which are called as Q0, Q1, Q2, Q3 and Q4. So 5 quartiles are there, right? So Q1, Q2 and Q3, these 3 quartiles are the important ones, because Q1, Q2 and Q3, these quartiles divide the entire data into 4 equal parts: 25%, 25%, 25%, 25%, right? So Q1, Q2, Q3, these values, these positions in the entire data will be the most important ones. And of course, Q0 and Q4 are the end points. Okay, so how do I get the median and how do I get the interquartile range? So to get the median, you need to understand what kind of data is given to us, whether it is an even numbered data or whether it is an odd numbered data. So there are 2 different ways in which you can do this. So I'm going to tell you just one method which is there in our textbook as well. So you will always follow that method to find the median and the interquartile range. So this method is applicable for both the even numbered as well as the odd numbered data. You don't have to learn 2 separate methods to get the answer. So to find the median, what you should be doing is you should be finding n upon 2. Try to get this value where n is what? N is the number of observations. Okay, n upon 2. This value I'm going to call as r. Okay, this value n upon 2 is called as r. Now, if this value r is an integer, okay, if it is an integer, for instance, if I have 16 values, so 16 divided by 2, that gives me 8. So that is what? 8 is an integer. But if I have 15 values, so if I do 15 divided by 2, so I get 7.5. So this 7.5 is lying between 7 and 8, right, students? So this value is called as R. R is taken as 7, and this value is called as R plus 1. Okay, so this 8 is called as R plus 1. Whereas if you have an integer, it is straight away called as R. So try and understand, try and remember this concept very thoroughly, students. In your data, first of all, see how many observations are given to us, how many scores are there. Okay, so I'm going to call that value as n, capital N. The number of observations or the number of scores is called as capital N. So if you have n, let's say 16, and if you divide it with 2, you get 8, which is an integer. So that's one type of data. And let's say if the value of n is 15, which is odd number data, you divide it by 2, you get 7.5. 7.5 is a value between 7 and 8. So 7 is taken as R, and 8 will be R plus 1. So this is not an integer, right? This is not an integer, whereas this is an integer. So whenever you have an integer, okay, so you have got 8. So this 8 is the rth value, rth position. So the 8th position, the value which is present at the 8th position. So the median will be the average of 8th and 9th observation. You want to remember this, okay? This is how you find the median if the value of n over 2 is an integer, okay? And if it is not an integer, then the r plus 1th value, the r plus 1th observation, this becomes your median. Very simple, okay? So remember, if n over 2, now this is true for the quartiles also. The first quartile Q1 is given by n over 4, and the third quartile Q3 is given by 3n over 4. So if n over 4 is an integer, if it comes an integer, then what you do, you, let's say this value is called as R. Then what you do is you take the rth value and you take the r plus 1th value. So rth value and r plus 1th value, and you find the average of these two values if it is an integer. If it is not an integer, then you find out this value, whatever the value you have got, lies between which two values. Okay, so that's r and r plus 1th value. So straight away the r plus 1th value is going to be your first quartile, and that is again true for the third quartile also. Again, if you get an integer, whatever the value comes, let's call it as r, then the third quartile is the average of r and the r plus 1th observation. Okay, r and the r plus 1th observation. And if it is not an integer, then this value will lie between r and r plus 1. Okay, so the r plus 1th value becomes what? It becomes your third quartile. And how do I get the interquartile range? So interquartile range is simply the difference of third and the first quartile. So you just do Q3 minus Q1. That is how you find the interquartile range, you find the median. Okay, so I hope this concept is pretty clear to you all. So I'm going to now start solving the question. Let's very quickly solve the question. It's for 3 marks. Okay, very simple question for 3 marks. So you are easily going to get your answer. So to get the median, or I'll begin like the first quartile, the second quartile, and the third quartile. The second quartile is your median. So first quartile, that's Q1. Okay, first quartile, which is Q1, it is given by n over 4. So n is the number of observation. N is the number of observations. So how many observations did we have? Rebels and the Sharks, both of them. It is 15 observations, right? So I just want to find the median and the interquartile range for the Rebels. So I'm just going to focus my attention on the Rebels data. So n number of observations, that is 15. So that's going to be 15 over 4. Okay, so very quickly, let's take the help of a calculator. So we have 15 divided by 4. It's 3.75. It's 3.75. So this 3.75 lies between third and fourth observation, right? It's not an integer, right? It's not an integer. So if it is not an integer, you find out which are the two values where in between this 3.75 is going to lie. So this obviously 3 and 4. So the fourth observation becomes your first quartile. So Q1 is the fourth observation. So you are going to now see what's the use of writing the total count of the leaves. So we are solving for what? We are solving for the rebels, right? It is you are on the left hand side. So you can see in the very first row you have three values, right? In the very first row you have three values. Then the fourth value is here, right? It's 80, not 0, right? It's 80. So 80 becomes your first quartile. So the fourth observation is 80, right? So I've got the first quartile. Now let's get the second quartile. So as I said, the second quartile is actually your median, right? I want to get my second quartile, which is the median. So Q2 is going to be 2 times of n over 4. So that's simply n over 2, n upon 2. That's 15 upon 2, which gives me 7.5. And it lies between 7 and 8. So therefore, I can say Q2 is going to be the 8th observation, right? So let's find out what's the 8th observation. So you can observe. So I'll just start counting. So in the very first row, there are 1, 2, and 3 values. That's 4, 5, 6, 7, and the 8th value, right? So that's 84. So I'm going to write my median as 84. That's your median, students. Okay, so make sure that you highlight it. So this is your median, because that's the first part of the question, right? Now let's very quickly get the third part as well. The third part means the third quartile. Let's get the third quartile. So that's Q3. It's going to be 3 times of n over 4. So that's 3 times of n was 15 divided by 4. I already had the value of 15 upon 4. It was 3.75. You just multiply this value with what? Multiply it with 3. So that's 45 over 4, or you can say 11.25. Again, it's not an integer. 11.25 lies between 11 and 12. So therefore, I can say Q3 is your 12th observation, which is going to be what? So your 8th observation was 84. 8th observation. So 8, 9, 10, 11, and 12. So that's your third quartile. It's going to be 93 over here. That's 93. Okay, so I've got the first quartile. I've got the second quartile, which is the median. And I have also got the third quartile. So now I simply want to get the interquartile range, right, students? So interquartile range is going to be what? So let's quickly write the interquartile range. So that's IQR. It's simply given by Q3 minus Q1, the difference of the third and the first quartile. So that's 93 minus 80. So I'm going to write here 93 minus 80. That gives me what value? So that's 13, right? 93 minus 80. Let's always confirm your answers. That's 13. So that's the interquartile range, right? And that's how you complete your B part of question number 6. Pretty simple, right? So first thing that you need to do is get the back-to-back stem and leaf diagram. And the second thing that you wanted to do is to get the median and the interquartile range for the rebels. Now, let's see the next part also of the question. So a box and whisker plot for the sharks is shown below. So can you see the box and whisker plot? You are already aware of what a box and whisker plot is. So there is a box in between, then there is one vertical line inside the box which gives you the median, okay, and then you have the whiskers, okay. So this This is called as a whisker. Okay, so this value is your first value, that's q naught. This is your first quartile, this is your second quartile, which is your median as well. This is the third quartile, q3, and that's q4. Any value which lies beyond this particular value. So if I say x, it is q3 plus 1.5 times of IQR, and x q1 minus 1.5 times of IQR. So any values which lie beyond q3 plus 1.5 times of IQR and q1 minus 1.5 times of IQR, these values, if you recall, are called as the outliers. Okay, we call them as the outliers. So if the question demands to identify which values are the outliers, you want to first get the value of x by using the formula q3 plus 1.5 times of IQR and q1 minus 1.5 times of IQR. Those values which go beyond these two values, those values will be called as the outliers of the data. So you can observe this q naught is given to us, and see, it is q naught. If you observe, can you see q naught? It's coming over here, right? So that's 65. This is 66. So you can observe here, your first value was 66. The last value is 92. So you can again come back over here. See, that's 92, right? This is 92, isn't it? So these are your extreme values. So this data is for what? This is for the sharks. So on the same diagram, I want to now plot for rebels. Okay, so I want to plot rebels. Let's remove all this stuff that we have already mentioned on the data. So I'm going to start drawing the box and whisker plot for the rebels. Okay, so for the rebels, what's the very first value? You can observe the very first value is 75 and the last value is 102. Okay, so 75 and 102. So 75 is going to be here. That's 75 students, right? Let's make a very proper diagram. That's 75, isn't it? And then 102. So you have 102 over here, right? This is 102. Then what's q1? You have got the value of q1 for the, isn't it? Q1 it's 80 and q3 it's 93. So 80 and 93 are the next values. So 80 is over here. This is 80, right? And then you have 93. So this is where you have 93, right, students? This is where you have 93. Complete the box. Let's quickly complete the box. Okay, draw the whiskers. Let's draw the whiskers. So the whiskers are also made. And you also want to represent your median. So where is the median, students? It is 84. So let's draw the median also. It's 84. So it's going to be here. Got that? So I know this value over here is q naught. This is q1. This is q2. This is q3. And this is q4. Right? So this is the box and whisker plot for what? This is the box and whisker plot for the rebels, right? So in the same diagram, we wanted to make the box and whisker plot for the rebels. Now, what is asked? What is asked over here? Make one comparison. Of course, I can make a lot of comparisons over here. Okay, Make one comparison between the weights of the players in the Rebels club and the weights of the players in the Sharks club. Okay, so I know this was Q0, this is Q1, this is Q2, Q3, and Q4 for the Sharks, right? So Q0 was 66. Q4, if you try and see, it is 92. So what's the range for Sharks? So range. So if I want to get for Sharks, it's going to be 92 minus 66. 92 minus 66. Very quickly, let's get that data also. 92 minus 66, it's going to be 26. And for the Rebels, it's what? 102, and it was 75. So 102 minus 75. So let's quickly get that value also. 102 minus 75. So that's 27. So that's the range. Okay. That's the first comparison that you can do. The second comparison is about the median weight. Okay, so the median weight of Sharks is how much? It's 76, right? It's for the Sharks, it's 76. So I can write here median. So again, for the Sharks, it's 76. And second, for the Rebels, how much it is? For the Rebels, it was 84, right? So can you say that the Rebels, the average weight, the mean weight, you can say, is greater than the average weight of Sharks? So that's the second comparison that you can make. You can also get the interquartile range. Okay, so any of these comparisons can be told. So generally what they expect is the comparison of median. Okay, so you always want to include this comparison definitely, but then you can also give other comparisons if you want. Okay, otherwise it's all fine. So if you want to get the interquartile range, so first one I'm going to get for Sharks, and the second one I'm going to get for the Rebels. Okay, so for the Sharks is going to be what? I want to get Q3 minus Q1. So you can see Q3 is Q1 is for the Sharks, it's 72 over here, and Q3 is 84. So I do 84 minus 72. 84 minus 72, that's 12. And for the Rebels, we have already got it, right? It was 93 minus 80, that's 13. This was 13. So that's the interquartile range. So the range and the interquartile range does not have much difference, but you can see that the average weight, the median weight for the Sharks and the Rebels, there is a difference, isn't it? You can see that the Sharks are weighing, average weight is 76 kilos and Rebels are weighing 84 kilos. So the weight of Rebels is higher than the average weight of Sharks. So that one comparison you can definitely say. So average weight of Rebels is higher than Sharks. Okay, so that's the comparison that we have done. So that's how you complete part C and part D of question number 6, right? So question number 6, you can observe how many marks you have scored until now. So that's 4 marks, the first part. The second part was for 3 marks, so that's 7 marks. Then you have 2 plus 1, so that's another 3, so that's 10 marks. So students, representation of data, a very simple chapter, has given you 10 marks. Now we proceed to the most important question of the paper and from your syllabus, question number 7, which is based on normal distribution. Okay, so you want to really pay attention over here for this last question. So I hope that's the last question. This is the 7th question. Yeah, that's the last question. So students, we are going to solve this question number 7. It's for 5 plus 3, that's for 8 marks, and another 3, that's for 11 marks. So huge weightage. Okay, so you really want to pay attention for this question. So what does the question say? The times in minutes that Carlyle spends each day on social media are normally distributed with mean 125 and standard deviation 24. So you know how to represent a normal distribution, right? Let's say X is a random variable. And when you say normal distribution, it is usually a continuous random variable. I hope you are pretty clear with that concept. So if you have a random variable and you are saying that that random variable is distributed normally, then in general, the random variable is a continuous random variable. Of course, for a discrete random variable also, you can have normal distribution, but most of the times a normal distribution is used for continuous random variable. Okay, so X represents a normal distribution. So how do you give the parameters? Do you recall that the parameters are given by mu and sigma square? What's the mu? Mu is called as the mean, and what's sigma square? That's the variance, and what's sigma? That's the standard deviation. Okay, I hope you are pretty clear with the terminologies over here. Mu means mean, sigma square is the variance, and sigma is called as the standard deviation. Okay, so it is told to us that Carlyle spends each day on social media are normally distributed with what mean? Mean is 125. So I can say X follows normal distribution with mean as 125 and standard deviation is 24. So I write here 24 square, right? Be very careful, students. Okay, it's variance that you include as a parameter for the normal distribution and not the standard deviation. Okay, so it's 125 comma 24 square. Now what does the question say? The first question is for 5 marks. Okay, so it's really an important question. So it's going to fetch you 5 marks. So please pay attention. So it says on how many days of the year, that means 365 days, would you expect Carlyle to spend more than 142 minutes on social media? So students, I am pretty confident that you already know what the graph for a normal distribution looks like. So it's a bell-shaped curve, isn't it? So if I draw a bell-shaped curve like this for the data, okay, that's a bell-shaped curve. That's your x-axis. Okay, and then you also draw the y-axis. Fine. So of course I'm going to keep it exactly at the center. This will be exactly at the center. Okay, so this is the mean, students. This is the mean of the data. So this is actually mu. This is mu. Okay, now this data is represented using two different variables. One is a variable x, which is given to us, and the other one is the standard normal variable, which is given by z. So for both of them, the graph remains exactly the same. Okay, the graph is always a bell-shaped curve. So mu is 125 here. Mu is 125, and here you get z. This is 0. Okay, so this is z bar, you can say. So standard normal variable is denoted by z, and where the mean is given to us as 125, then the mean of z becomes equal to 0. So you want to really know this well. So x has mean x bar, z will have mean z bar. So x bar is 125, z bar is going to be 0. Okay, now let's proceed further. So you can observe, you want to find on how many days of the year would you expect Carlyle to spend more than 142 minutes on social media, more than 142. So on which side of the graph you can see 142? So that's the value of x, students. This 142 that you can see over here, that's the value of x. Okay, so of course 142 lies beyond 125, isn't it? So it's going to be here, let's say. So I'm going to draw a vertical line. I'm going to draw a vertical line denoting 142. Okay, so that's the line which is x bar, not x bar, x as 142. So this is where x is 142. X is 142. So there will be some value of z. Okay, so that value can be called as maybe z or sometimes z1. It's entirely your choice what you want to call that. So area under this curve, the curve that you can see, the bell-shaped curve, so area under the curve is always 1. The probability is 1. The total data is going to give you the probability as 1, right? So you want to find the probability when x is greater than 142. You getting that? So you want to find the probability of x greater than 142. Probability of x greater than 142. Now, you should know how this x is transformed into z. So I will write here probability of z greater than some value of z. So for x equal to 142, there is some value of z. For x equal to 125, what was the value of z? The value of z was 0, right? For the value of x as 125, the value of z was 0. When the value of x becomes 142, what's the value of z? That is what you want to find. And you want to find on how many days Carla is spending more than 142 minutes on the social media. So actually, I have to find the area under the curve after 142. Okay, I want to find the area under the curve after 142. Okay, so that's my question. And then this area will give you the probability. This area is going to give me the probability. This probability, when I multiply, so it's like this. Once you get this probability, you simply want to multiply it with the 365 days. Okay, so that those many days you will find that Carla is spending more than 142 minutes on social media. So the first thing that you need to do is to get the value of z. So you should be aware that z is given by the formula x minus mu divided by sigma, right? The value of z is given by x minus mu divided by sigma. So when x is 142, when x is 142, z is going to be 142 minus the mu value was 125 divided by the value of sigma. It was 24. Let's quickly get this value. So it's going to be 142 minus 125, and that gets divided by 24. So that's 0.7083. So I write here 0.7083. That's the value of z. So I'm going to write here this z is going to be 0.7083. So finding the probability of z greater than 0.7083. So when I say x is greater than 142, it means z is greater than 0.7083, right? I want to find the probability of z greater than 0.7083. So now I'm going to share this table with you. Okay, you are already aware of this table. Okay, so this is what the z table is. Okay, now this table will always give you the area under the curve after a particular value. Okay, after a particular value, in the sense, if you have, see, the diagram is also mentioned over here, isn't it? You can observe, look at this diagram. Okay, this is some value of z. So it is before this value of z. So always remember, the first thing that you need to know is your z should lie ahead of 0. Ahead of 0, right? Positive value. If it is negative value, still you can get the answer, but the table does not give the answer for negative values of z. So I'm trying to tell you like this. So if you have this Z over here, then the table does not give you the area under the curve before this negative value of Z. Okay, the table will always give you the value or the area under the curve for that value of Z, which lies on the right of Z equal to 0, right of Z equal to 0, and before this value. Okay, students, try and understand this well. Okay, I'll explain it one more time for you. Look at this. The table always gives you the area under the curve before the value of Z. Okay, whatever the value of Z is given to you, before that, whatever area is shaded, that's the area under the curve. Okay, if this value of Z is negative, so this was Z equal to 0, right? If this value of Z is negative, so the table cannot give you the answer for this part. Okay, the table does not give you the value of area under the curve before this negative value of Z. For that, there is a different approach. So we are going to take a look at that as well a little later. Okay, the next part of the question is based on this concept only. So this is what you always want to remember. Okay, so now I have the value of Z, which was 0.7083. I hope that's the correct value that I've taken, right? Yeah, 0.7083. It is definitely, it's of course I can say it's a positive value. It's ahead of Z equal to 0. So I just want to now go and see for 0 point, the table value 0.7 below 0 with add value of 8. 3 is having no significance over here. There is no 70, it's 0.7. Okay, so you can see this is 0.7 over here. See, you can see 0.7 below 0, that's 0.758 with an add value of what? So it was 0.7083. So that's 8. So this is 8 over here. So just extend it over here and then below 8. So that's 24. So to this value 0.7580, you want to add 24. So it's like 0.7580 plus 24. So 0 and 4 will get added. You get a 4. 8 plus 2, that's 10. 0, carry 1. 5 plus 1, that's 6. 0.7604, right? 0.7604. So I will have here, this is equal to, now again, very important. I have given you the value of phi of Z equal to 0.7083, right? Phi of Z equal to 0.7083, and that value has come 0.7. Let's quickly take a look at that value. 0.7604. 0.7604. What do you mean by this? So if you, I'll just quickly make the rough diagram. If you make a bell-shaped curve, this is where Z equal to 0.7083 is. Okay, so before this value 0.7083, how much data is lying? So before this value, around 76% of the data is lying. So it's 0.7604. If you multiply it with 100, it's 76.04%. So before this value of Z, there is 76% of the data that is lying. But is that the question that is asked? The question is not asked for Z less than 0.7083. We are requiring to find this part of the area under the curve, right? So it's going to be what? It's going to be 1 minus total area under the curve is how much? Total area under the curve is 1. So to find 1 minus, if you want to get this area, it's going to be 1 minus this value, right? So if I do 1 minus 0.7604, whatever answer comes, that's the area under the curve when Z is greater than 0.7083. Now, these are very close values. You might get a little confused over here. So try and understand. When X was 142, right? When X is 142, Then the value of Z came 0.7083. Okay. And from the table, I've got the probability of Z equal to 0.7083, and that has come 0.7604. That means 76.04% is the total value. That means 76% is the chance that Carlyle will spend less than 142 minutes. Carlyle will spend less than 142 minutes on social media. So for how much time she'll be spending more than, what's the probability of Carlyle spending more than 142 minutes? It will be 1 minus, right? The probabilities, the total probability is always 1. The area under the curve is always 1. So I know this region of the curve. I know this region. I know the area under this part of the curve, isn't it? This is what the table will give me. The Z table gives me always the value for Z equal to some value is there. Let's say Z1. So it always gives me the value of the probabilities before that particular value of Z, before. Okay. And this value of Z should always lie on the right of Z equal to 0. Okay. It should always lie on the right of Z equal to 0. So now I can clearly understand what region I want to find, isn't it? So I can see I have to find this region, isn't it? This is to be found. Table gives you this value. Table gives this part. Okay, so the required region, the area under the required region will be given by what? It's going to be 1 minus phi of Z equal to 0.7083. So it's going to be 1 minus 0.7604. So that will come how much? So 1 minus 0.7604, it has come 0.2396. 0.2396, right? So that means I can say there is 23.96% chance, 23.96% chance Carlyle spends more than 142 minutes on social media. You got that? Carlyle will spend more than 142 minutes on social media. That's 23.96% chance. So for the entire year, out of 365 days, there is 23.96% chance that Carlyle will spend more than 142 minutes on social media. So I'm going to write it that way now. So therefore, in 1 year, total days spent by Carlyle on social media is 0.2396 multiplied with 365. So what's the answer going to be? It's 0.2396 multiplied with 365. That's 87.454. So 87.454. So that's 87 days, right? So 87.45, you can maybe take it as 87.5 for 88 days as well. So I'll complete days is 87. So therefore I can say 87 days. Okay. So I'll write over here, it's 87 days. Okay. Or you can also write 88 days. If you also take in account the 0.454 part of the answers, that's 87 days or 88 days is the number of days where Carlyle will spend more than 142 minutes on social media. So can you see question number 7, part A the first sub question, how the question was solved. It was for 5 mark students, so you really need to know the concept. Okay, so make sure that you study your normal distribution very thoroughly. So that was your first part. Now let's move on to the second part of the question. Now find the probability that Carla spends more than 142 minutes on social media on fewer than 2 out of 10 randomly chosen days. So you want to now really understand, students. I have seen students struggling with identification of the questions, which question belongs to which topic. Now the first part was definitely of normal distribution, right? Out of 365 days, tell how many days Carla spends more than 142 minutes on the social media. So n was pretty large. It was 365 days. So what I did was I simply got the probability when Carla will be spending more than 142 minutes on social media. I got the probability, and that probability I simply multiplied with the total number of days, 365, right? But here, what you have done, so find the probability that Carla will spend more than 142 minutes on social media on fewer than 2 out of 10 randomly chosen days. So you want to first of all select 10 days. Okay. And in these 10 days, you want to find the probability that Carla will be spending more than 142 minutes on social media for less than 2 days. So basically, this question belongs to binomial distribution. So there are 10 days, isn't it? So out of 10 days, how many times you need to be successful? Success is what? Spending more than 142 minutes becomes your success, right? If Carla is spending more than 142 minutes, that's a success. And this success needs to be happening for fewer than 2. Okay, less than 2. So fewer than 2 means what? Less than 2 is 1 and 0, right, students? Less than 2, fewer than 2. So fewer than 2, you clearly want to understand. It's not 2 or less than 2. It is less than 2, fewer than 2. So out of 10 days, less than 2 days, Carla will be spending 142 minutes. So that's definitely a question on binomial distribution, right, students? So you know, for a binomial distribution, how do we write? So if X follows a binomial distribution, then the two parameters that you want to write is what? It's N and P. So N is a number of trials, isn't it? So here it is 10, isn't it? N is 10, number of trials, it's 10, and P is a probability of success, and that's how much? When does Carla spend more than 142 minutes? So it's 0.2396. So is it okay if I write this value as 0.24? Of course I can write, right? So as a instruction that is already given to us is to write either 3 significant figures, isn't it? So that's 0.2396 will definitely become to 0.24, or if you have an angle, then you want to write up to 1 decimal place. So I'm going to write 0.24 as my probability of success. So it's 0.24. So I should be writing now X follows binomial distribution where the number of trial is 10 and the probability of success is 0.24. Okay, and on how many times I should be successful? Fewer than 2. So I want to find probability of X less than 2. So X is less than 2 means what? Probability of X equal to 0 or X equal to 1. And now I'm pretty sure that you already know the formula for the binomial distribution. Okay, so probability of X equal to X, it is given by what? It is given by NCX, P raised to X, Q raised to N minus X. Q is the probability of failure, N was the number of trials or number of trials, and then X is the number of success, P is the probability of success, right? And Q was the probability of failure. So I can now write N, which is 10, C, X is 0. So I write 0. Probability of success, it is 0.24 raised to X, which is 0, and 1 minus 0.24. So Q is 1 minus P. So 1 minus 0.24. So I'll write here 1 minus 0.24. That's definitely going to be 0.76. So that's 0.76. So I'll write here 0.76 raised to what? 10 minus 0. So it's simply 10 and then plus 10C1, 0.24 raised to 1, 0.76 raised to 10 minus 1, and that's 9. So you want to simplify this well. So I can write a probability of x less than 2 is going to be, so you have the calculator, you can make use of it and very quickly get your answer. So 10C0 is going to be 1, 0.24 raised to 0 is also going to be 1. So it's just 0.76 to the power 10. 0.76 to the power 10 plus 10C1. That's 10 multiplies with 0.24 raised to 1. That's simply 0.24 multiplied with 0.76 raised to 9. Let's quickly get this answer. So I'm going to make use of the calculator. 0.76 to the power what? To the power 10, right? Then plus 10 multiplies with 0.24 multiplies with 0.76 to the power 9. Got it? So my answer has come 0.2673. So it is just 26.73% chance that Carla will be spending more than 142 minutes on social media on fewer than 2 out of 10 randomly chosen days. So that's the second part of the question, which has fetched you another 3 marks. So this was a question on binomial distribution, students. Okay, now we are going to proceed on to the B part of the question. Again, an important question. Now, what's the question telling us? On 90% of days, Carla spends more than 10 minutes on social media. So try and understand whatever number of days you have taken. Okay, it might be 10 days, it might be 15 days, 100 days, or 365 days, whatever number of days you have taken. On 90% of those days, Carla is spending more than 10 minutes on social media. More than 10 minutes. You getting that? Find the value of t. Again, a very important question, students. You really want to understand. You want to really pay attention. Okay. So always remember, you first want to identify whether the question belongs to binomial distribution or normal distribution. So in this question, you are given the probability that 90% of the times, what happens? Carla spends more than 10 minutes on social media, right? 90% of the time. In your question over here, in this question, if you recall this graph that you can see now on your screen, in this graph, 76% was the probability of Carla spending less than 142 minutes, right? Less than 142 minutes. So it was 76%, and only 24% times Carla was spending more than 142 minutes. 24%. So can you see 76% is a major chunk of the graph, right? So now you want to understand that 90% is going to be the major chunk of the graph. So 90% of the time Carla is going to spend 10 minutes, right? More than 10 minutes on social media. So try and understand this. If you draw the graph like this, that's the graph of X, and that's the graph of Z as well. That's the mean. I know X bar is given by what? X bar is 125. That's the value of mu. What's Z bar? It's 0, right? Now, there will be T somewhere, isn't it? I don't know where this T is going to be, but Carla will be spending more than 10 minutes on social media. So if I take T on this side, let's say this is X equal to T. There will be some value of Z, let's say Z1, I don't know. But then 90% of the days, so 90% times, Carla should be spending more than 10 minutes. So 90%, so this value should be 90%. Students, is that possible? Can this region be 90% of the entire curve? Area under the curve should be 90%. Can this region be 90%? The answer is no. See, you want to find Carla, finding the probability when Carla spends more than 10 minutes. So this is T, this is X equal to T, and more than T will be definitely what? definitely ahead of this x equal to t, right? Ahead of x equal to t. So this area under the curve ahead of x equal to t should be 90%, but by looking at the graph, it can be clearly understood that this region that I've shaded cannot become 90%. That's totally wrong, right? But if I now place my t over here, is x equal to t, whatever the value is, so it will be definitely less than 125. And now if I ask you this region, this entire region, can this region be 90%? So up to this part, I know this region is 50%, this region is 50%, and the remaining region needs to be 40%. So you can now clearly understand that the value of t is definitely less than 125. And if the value of t is less than 125, the value of z is going to be negative. Very important, students, that the value of z is going to be negative. So you want to clearly understand this, that when is z positive and when is z negative. So for that, you need to first of all know that the value of the graph of, not the value, the graph of x and the graph of z are one and the same graphs. For particular value of x, there will be a respective value of z. Okay, so I know that for x equal to 125, which is the mean, the value of z is going to be 0. So any value which is now ahead of 125 will give you a positive value of z, and any value which is before 125, less than 125, will give you negative value of z. Also, you want to take care of the area under the curve. So I said that 90% of the times Carla is spending more than t minutes. So 90% is a major chunk of the curve. Okay, so area under the curve needs to be 90%. So there are only two ways. So either this is 90% or this is 90%. Okay, but now this is less than, this is less than, and this is greater than. Okay, and I want to find greater than. So this is the correct graph. You got that, students? I hope this concept is pretty clear to you all. So I'm going to erase all this stuff now. I'm going to draw a very good diagram. Okay, because we are writing the solution for the Cambridge exam. So I'm going to draw, first of all, a proper graph. Okay, let's draw a proper graph very quickly. So I have a bell-shaped curve over here. Okay, let's quickly draw a bell-shaped curve, right? Let's draw a horizontal line. Let's draw a vertical line as well. You know what this line is, isn't it? This is the line of z equal to 0. Let's place it exactly at the center. So before this, 50% values are there. After this also 50% values are there. Okay, so this is where x is 125, right? And this is where z is going to be 0, right? So now I know that t is going to be where, right or left? It is going to be on the left of x equal to 125. Okay, so I'm going to draw a vertical line. So I am pretty sure that this concept, where does t lie, is very clear in your minds, right? Where this t is going to lie. So this is where I'm going to place the line. This is where x is t, right? So for this, there will be some value of z, and it is definitely going to be minus. It's going to be a negative value. Okay, and the region after this value, because I want to find x greater than t, right? So after this value, x is going to be greater than t, right? It's going to be greater than t. So let me be very careful with the boundaries. Okay, so in the exam, you need not be doing all this stuff. You can just use hatching lines to represent what region is required. Okay, so for me, the hatching lines are going to take too much time, so I just make use of the shading. Okay, so this is how the region is going to be. So this is where I can write x is greater than t, right? So probability of x greater than t is 90%. So probability of z greater than that negative value of z is also 90%, right? So you want to find that value. So it's now pretty simple, students. So how do I get all this stuff? So observe carefully. So probability of x greater than t is probability of z greater than a negative value of z, right? And this value is 90%. Now, again, try and understand. Whenever you are solving a particular question, the z table gives you that area under the curve where maybe there is some value of z as z1. So the z table is going to give you that value where z is less than z1, and this z1 always lies on the right, of z equal to 0. So before z equal to z1, and this z1 has to lie on the right. So of course, the shaded region, the green colored shaded region that you can see in my diagram, I am not going to get my value from the z table. Okay, for this region, this green colored region that you can see in my diagram, the z table cannot give me the value for this region. What it can do is it can give me the value for the counter region. So see how I'm going to draw the counter region. Observe carefully. So this region is exactly same as, so I'm going to draw another diagram just to make us understand what's going to happen over here. So again, this is the middle line, z equal to 0. Okay, so I know that this value is x equal to t. This is z equal to minus z. Okay, now there will be a counter value to this over here. Okay, it will be placed at the exact same distance. This is going to be x equal to some new value. Okay, maybe I can call this value as small x, right? But for this value, z is going to be plus z because it is exactly at the same distance. So this is what you really want to understand. And then the graph, I'm going to shade this region from the graph. Okay, I know the table is capable to give me this region, right? I'll just quickly shade this region. The table can give me this region, isn't it? So both the diagrams are exact copies of each other. So whenever you are solving a question for negative value of z, the table is incapable of giving you the area under the curve before the negative value of z, okay, or ahead of the negative value of z. The table cannot give you these values. So if I draw the graph and this is negative value of z, the table cannot give you this answer, and the table cannot give you this answer as well. Okay, these answers are not given in the table. So what we do, we find the counter values. We always find a counter value. So this negative z will have a positive z. So instead of getting this region, you get either this region, okay, and then this probability and this probability is going to be same, or if you want to find this region, okay, over here, so you again draw, find its counter value over here, and you find this region, it's one and the same thing. So this is how the table works. Okay, this is how the table is going to work. So now what I do, so probability of z greater than minus z is same as, probability of z less than plus z. Okay, less than plus z, and this probability is 0.9. So I am going to write again, this is equal to phi of z equal to plus z, and this is 0.90, 90%, so 0.90. So you want to see the sequence, how I have taken the sequence. So I wanted to find the probability of x greater than t. So this greater than t was lying on the left of z equal to 0. Why? Because I want to cover 90% of the area under the curve. Okay. For this value of x equal to t, there will be a negative value of z, but the table cannot give me probabilities for negative values of z. So I want to shift to the positive value of z, right? So this is how the sequence comes. So now if you go to the table, so for what value of z, for what value of z do you get 90%? So again, students, very important, you don't have to find 0.9. What value of z will give you 0.9 is what you need to find. Okay, so you will not go like this, you'll search for 0.9 and then see the probability. No, that's not the correct way. That's absolutely wrong. You already know what the probability is. You don't know for what value of z that probability is going to be there. 0.9 is the probability given to me, so I already know the probability is 0.9. I just want to find for what value of z this probability is 0.9. So it's reverse now. Okay, so instead of finding the probability is given, we are going to find z. So it's the reverse way. So now we go inside the table and look for 0.9. In fact, it is not needed. You can see here, when the probability is 0.9, the value of z is 1.282. You can check 1.2. This is 1.2, then 8. So 1.2 below 8. So it is here 0.8997 and then 2. Okay, so add value of 2. See, if you add 4 to it, it's going to be 0.9001. Very close value, right? So it can be 82 or 81 also. If you add 2, it becomes 0.8999, which is also very close value. So it depends, students. So you already know from the table that for 0.9, you have to take the value of z as 0.82. The value of z is 0.82. So I again go back over here. So I'm going to write so phi of z equal to 1.282. I get the probability as 0.9. That means the value of z is 1.282. But I want to find the probability of x greater than t. And for this x greater than t, the value of z was negative z. Okay, so this is very important, students. You really want to know this well. So I want to find the value of t. This is not known to me. And for this value of x equal to t, z is negative z. So it's negative 1.282. Now, you know how to find the value of z, right? So z is given by x minus mu divided by sigma, right? That's a formula for finding the value of z. Now I know what's the value of z. It's minus 1.282. So I write here minus 1.282. Then the value of x, I do not know. That is what I'm trying to find. That the value of that value of x is going to us as t, right? So I write t, and then minus of mu. That was the mean, isn't it? So do you recall that the mean was 125? So I write here 125 divided by sigma. So sigma was 24, isn't it? So mean was, let's quickly confirm the values, right, students? It's always better to confirm the values. So mean is 125 and sigma was 24. Okay, so I come back here and then I get the value of t. So it's minus 1.28 minus 1.282 multiplies with 24, and then 125 will get added to this. 125 gets added to this. It's 94.232. It's 94.232. So I can say that x greater than t, that is x should be greater than 94 point. So I'm going to write three significant figures. That's 9, 4 and 2. So 94.2. So this is how you can solve the last part of the question. So students, the last part was also an important discussion. Okay, I hope this discussion is pretty clear to you all. So that's how we have completed our question paper. We have scored a perfect A star, right? So that's a 50 marks paper. 50 on 50 is what we have scored in this particular question paper as well. So it's time for me to stop sharing my screen, students. Let me go ahead quickly and stop sharing my screen. So students, in this entire question paper, what are topics we have taken, I'm pretty confident that all the topics are well clear to you. But in case if there is anything that you need to ask, if there is any doubts, any topic that you want me to explain you, you can go to the comment section and you put up your doubts, and I'll make every effort to make sure that the doubts are answered. Okay, so that's how we are going to end this question paper. I'm pretty confident that all the things are very clear to you all. Make sure that if this video has helped you in any ways, then please go and subscribe my channel. That gives me a motivation to create more and more videos. Do like the video and share this video with your friends doing the same course. So that's all from my side. This is Pankaj signing off. Until we meet next time, you all have a great day ahead. Thank you very much for watching. Bye bye.